Hello, welcome to Astronautics for Exploit. I am Dr. Ayanshola Ogundele. Reasons for exploring Mars, human curiosity to break boundaries and replenish Earth-depleted resources. The focus points of my presentation are as follows: Mars exploration and reasons for Mars exploration. Over several years, and starting from the late 20th century, Mars has been researched and explored via various spacecraft and probes and has been the planet of human interest. As a result, knowledge has been gained about the Mars composition, geology, habitability potential, how it can be transformed into a form that humans can live and work, and usefulness to the humankind. Via various telescopic observations, it was revealed that there were changes in color of the Mars surface, and this was attributed to the seasonal vegetation. Also, through telescopes, Mars' two moons, Phobos and Deimos, were discovered. Polar ice caps and solar system's tallest mountain, Olympus Mons, was discovered. Mars has been employed to determine if life ever arose on Mars, to characterize Mars' geology and climate, and to prepare for the human exploration of Mars in the future. For better understanding of potential of Mars to be habitable, efforts are ongoing to determine whether there ever was life on Mars. Various research endeavors are being conducted to look for places on Mars where water is, was, or could possibly be. For example, dry-up river beds under the planetary surface and the Mars polar ice caps. Presently, both the current and past climate and geology of Mars, as well as factors that influence climate change on Mars, are being characterized. Also, to replenish depleted Earth resources, attentions have been directed at mining Mars resources for the betterment of humankind. Future Mars manned missions are also being planned. Mars exploration. Many strategic, practical, and scientific reasons have been attributed to the reasons why humans explore Mars. Mars is believed to be the most accessible place in the solar system. Mars is explored for the opportunity to possibly answer origin and evolution of life questions, and could someday be a destination for survival of mankind. The picture here shows deep space exploration. Research findings show that many of the key questions in solar system science can be addressed effectively by exploring Mars. This endeavor also serves to inspire the next generation of explorers and dramatically expand human knowledge. Mars has been explored remotely by spacecraft. Probes sent from Earth beginning in the late 20th century have yielded a large increase in knowledge about the Martian system, focused primarily on understanding its geology and habitability potential knowledge. The picture here shows an artist's concept of a few of NASA's Mars Reconnaissance Orbiter using its shallow subsurface radar instrument to look under the surface of Mars. There are various reasons for exploring Mars, and some of them are for future possible space tourism, preparation for future manned exploration, space mining, knowledge and science advancement, investigation of Mars climate, new technologies development, investigation of Mars geology, investigation of possibility of life. Space tourism. Presently, interested space enthusiasts and tourists are embarking on space tourism, such as orbital and suborbital space tourism. Also, plans are in top chair to send tourists around the orbit of the Moon. In future, there are space tourists who will be interested in sojourn to the Mars and perhaps even take trips around Mars. The picture here shows an artist's impression of Mars expressed. The Mars space tourism endeavors will help to improve engineering expertise with space docking, launches, and re-entry, and providing additional experience about the impact of space travel on the human body. Experience gained on weightlessness and low gravity situations by the space agencies and private space companies will help to prepare for future travel to the Mars. The picture here shows 3 views of Mars by Hubble Space Telescope. Preparation for future manned exploration. Mars is an obvious target for exploration because of its closeness by in our solar system. And one of the scientific reasons for going to Mars is to prepare for future human exploration. In the future, there are various plans to land humans on Mars. Various space agencies and private individuals are studying ways to build potential human habitats on the Mars by producing bricks from pressurized Martian soil. The picture here shows illustration of Mars exploration. Mars atmosphere. Samples of the Mars atmosphere could reveal crucial details on its formation and evolution, and also why Mars has less atmosphere than Earth. Exploring Mars will help us to learn more about the Earth. Understanding Martian geophysical processes promises to uncover details of the evolution and history of Earth and other planets in our solar system. All these endeavors will help to prepare humans for eventual landing on the Mars. The picture here shows NASA missions to Mars. Knowledge and science advancement. The Mars exploration rovers tell us of an ancient time when Mars was smashed in water with good conditions for supporting microbial life. There are different scientific theories. Mars space exploration activities have helped humans to prove or disprove scientific theories developed on Earth. The picture here shows an artist's concept of exploration rover on the surface of Mars. Knowledge and science advancement. Most significant discoveries and knowledge gained from Mars exploration are as follows. Discovery of the mineral hematite, which typically forms in water. At a place called Comanche, Spirit rover found rocks formed when Mars was warm and wet, 10 times richer in key chemicals than any other Martian rocks studied before. Rocks examined by Spirit Mars rover hold evidence of a wet, non-acidic ancient environment that may have been favorable for life. The picture here shows Curiosity rover. Other knowledge and science advancement are as follows. Opportunity rover study Mars clouds and dust, the opacity of its atmosphere, and how it affects the solar panels. This type of information will help inform future Mars missions. Opportunity rover learned about the lives of craters, how they form and erode through time. Spirit rover discovered that an ancient volcano erupted at home plate. This is a sign of a once-heated habitat. The picture here shows rover launched on 23rd July 2020 and inserted into Martian orbit. Investigation of possibility of life. To date, no proof of past or present life has been found on Mars. But cumulative evidence suggests that during the Ancient time period, the surface environment of Mars had liquid water and may have been habitable for microorganisms. But habitable conditions do not necessarily indicate life. The picture here shows Mars Curiosity rover detection of methane vents on Mars. In August 1996, a group of scientists announced that they had found evidence of ancient life on Mars This evidence included bacteria-shaped objects and organic chemical molecules, which was collected in Antarctica. Biological chemistry. Organic matter has been found on Mars by NASA's Curiosity and Perseverance rovers. However, it is not a conclusive sign of life since it could have been created by non-biological chemistry. The picture here shows seasonal frozen lakes, which appear throughout Mars. Origins and ubiquity of life. The place that Perseverance rover was designed to land was believed by the scientists to have had a lake filled with water and flowing rivers experienced about 3.5 billion of years ago. The Perseverance rover landing site is said to be an ideal place to search for the residues of microbial life, test new technologies, and lay the groundwork for human exploration down the road. The picture here shows artists' conception of an established Martian colony. Investigation of Mars geology. Mars is a terrestrial planet which has undergone the process of planetary differentiation. The geology of Mars is the scientific study of the surface, crust, and interior of the Mars. It emphasizes the composition, structure, history, and physical processes that shape the planet. Various Mars missions have been deployed to investigate Mars geology. For example, the InSight lander mission was designed to study the deep interior of Mars. The picture here shows global Martian topography and landscape features. Previous missions to Mars have investigated the surface history by examining features such as canyons, volcanoes, rocks, and soil. Although Mars has no evidence of a current structured global magnetic field, observations show that part of the planet's crust has been magnetized. An examination of the rock record of Mars highlights the importance of wind erosion in shaping the red planet. The picture here shows Mars Orbital Laser Altimeter. New technologies development. Going to Mars requires a lot of new technologies, such as propulsion systems, heat shields, spacesuits, mobility, energy and communications technologies. In the future, it is anticipated that Mars will be explored in large scale, and technologies developed for Mars exploration will be useful for the humanity and the Earth. The picture here shows an orbiting array of reflective balloons, focuses sunlight onto the surface of Mars and providing extra heat and solar power for human colonies. Space mining. Research findings show that some asteroids, moons, and planets are rich in minerals and rare elements. Ability to harvest the space materials in a safe and responsible manner and bring them back to Earth represents a possible benefit of space exploration. Mars could be used as a transit place for the transportation of the materials. The Mars Society prototype habitat is shown in this picture. Mars Oxygen Experiment mission could help resource utilization through oxygen experiment equipment that converts Martian carbon dioxide into oxygen and will help humans live and work on the Mars. Concept of mining on the Mars is depicted in this picture. Investigation of Mars climate. Of all the planets in the solar system, the seasons of Mars are the most Earth-like, due to the similar tilt of the two planets' rotational axes. The lengths of the Martian seasons are about twice those of Earth, as Mars' greater distance from the Sun leads to the Martian year being about 2 Earth years long. Martian surface temperatures vary from lows of about minus 143 degrees Celsius to highs of about 35 degrees Celsius. The picture here shows Mars without a dust storm in June 2001 and with a global dust storm in July 2001. Perseverance was designed to study Martian climate and welder, test technologies that could help humans survive on Mars and collect samples. The Mars Surveyor 98 program was comprised of 2 spacecraft launched separately, the Mars Climate Orbiter and the Mars Polar Lander. Mars Global Climate Zone is shown in this picture. Mars Climate Orbiter. The Mars Climate Orbiter and the Mars Polar Lander missions were to study the Martian weather, climate and water and carbon dioxide budget, so as to understand the reservoirs, behavior, and atmospheric role of volatiles, and to search for evidence of long-term and episodic climate changes. The Mars Climate Orbiter was destroyed when a navigation error caused it to miss its target altitude at Mars by 80 to 90 kilometers instead of entering the Martian atmosphere. The picture here shows large dust storm on Mars. For more information, contact Astronautics for Exploit. You've been watching and listening to Reasons for Exploring Mars, Human Curiosity to Break Boundaries and Replenish Earth-Depleted Resources, presented by Dr. Ayanshola Ogundele, with the focus points Mars exploration and reasons for Mars exploration. Thank you.